Number 26. Assume that 5.60 liters of H2 at STP, right? So we know the temperature and pressure, react with copper 2 oxide according to the following equation. So make sure that the equation is balanced before beginning your calculations. And that's something that we should always do, right? We should always make sure that our coefficients are correct and usable. Because once we start drawing our crosshairs, we don't want to stop, right? It's a nice flow thing. So we got one carbon, is it not carbon? One copper on each side. Right now I have one oxygen on each side, and I have two hydrogens on each side. So looks like we're good. So that means it's a 1 to 1 to 1 to 1 ratio. How many moles of H2 react with this volume? Okay, so we're at STP. So 1 mole of any gas is going to occupy 22.4 liters. So that's what I can use for my conversion factor. How many moles of H2 react? Well, this, actually, sorry, we're going from H2 to H2. We don't need to use these coefficients yet. Getting ahead of myself. 5.60 liters of H2. Liters of H2. I can go directly into moles of H2 using my standard molar volume, right? Standard because of standard temperature and pressure. 1 mole occupies 22.4 liters. And time to calculate. 5.60 divided by 22.4. Up with 0.25. I need 3 sig figs. So I'll add a 0. Moles H2, right? Because liters cancel. All right. And how many moles of copper are produced? Now, you can go from either one of these values, right? You can go from liters of H2 to into moles of H2, and then use your mole to mole ratio to be right there, right? That 1 to 1. Or you can take a molar amount that you already know exists, that's being used or being produced, and you can go straight from this unit into that species. Either or, you will get the exact same answer. For the purposes of this video, I'm going to start from what the question gives me. So I'm going to go 5.60 liters of H2. Then I'm going to use standard molar volume to go into moles of H2. Now that I'm in moles of H2, I can use the mole ratio of hydrogen to copper, right? Because I was given hydrogen, I'm being asked for copper. We go from moles of H2 into moles of copper. So I see that liters of H2 will cancel, then moles of H2 will cancel, and my answer will be in terms of moles of copper. So let's fill this in. 1 mole at STP occupies 22.4 liters. This is a 1-to-1 relationship. So again, without even doing calculation, I know it's going to be the same as that. 0.250. Again, I'm adding that trailing 0 so I can have 3 sig figs right there. And then how many grams of copper are produced, right, from this amount of copper. But again, you can start from this value, right, that the question gives you. You can start from that value. You can start from that value. All of these will give you the exact same answer. But for the purposes of this video, I'm going to start with what the question gives me to start with. Just so you can see the entire problem, because I, on a test, can give you that number, this equation, and then skip right to this question. Okay, and so you want to be able to set up this entire thing from the get-go. Liters of H2 into moles of H2. Then I can go moles of H2 into moles of copper. And then using the molar mass of copper, go into grams of copper. Again, liters of H2 cancels with liters of H2. Moles of H2 cancels with moles of H2. Moles of copper cancel with moles of copper. And I end up with grams of copper. So 1 mole occupies 22.4 liters at STP, which is what we are. That's a 1-to-1 molar ratio. And then 1 mole of copper, looking at the periodic table, has a mass of 63. I forgot I had to check. 63.55 grams. Now I'm still going to report my answer with 3 sig figs because this is limiting me over here. But we are all set up. Time to do some calculations. 5.6 times 63.55 divided by 22.4. We end up with a number 3 sig figs, so 15.9 grams. So 15.9 grams, 3 sig figs, right? 3 sig figs, grams of copper. Now again, any of these questions can be asked at any time. You don't have to go A, B, C in this order, meaning you can do B by itself having not done A before it. You can do C by itself without having done A or B before it, right? And the way you do that, notice that the first step in each of these 3 conversions, right, was going from liters of H2 and then using standard molar volume to go from liters of H2 into moles of H2. And then once I was in moles of H2, I could do any number of things. For here I went into moles of copper, used the mole ratio to go from talking about the species H2 into talking about the species Cu. And then lastly I used the molar mass of copper to go from moles into grams.